Okay, this unit right here, we're going to talk about, what do they call it? They call it units of measure. All right. It's actually before page 1. They call it P4. I don't know what the P stands for, but it's page P4. It's at the very beginning. It's section 01. All right, so look for section 01. It's right at the beginning. It's kind of like a review lesson. So we're not really technically doing geometry yet. This is just review, just to get some basic skills down pat before we start in the actual geometry stuff. All right, we talked about this. It was this class, wasn't it, where I showed the meter stick and all that. So I teach this twice, and I didn't do that for the other class. I was just trying to remember which one I did it. Okay, so here's just a quick review. This is a meter. Okay, 1 meter, and how many of these things right here does it take to make a kilometer? It's right in front of you. It's right in front of you. Look at it. 1,000, right? 1,000 of these. So if I got 1, 2, 3, 4, and I went to 1,000, that's pretty long distance, isn't it? All right, that's 1 kilometer. Now, 1 kilometer, we'll talk about this maybe a little bit later, but like you measure the distance that you drive in a car by kilometers. That's how long it is, okay? It's not as long as a mile. I think, if I remember right, it's like 1.6. I wish I would remember. It's like 1.6 kilometers per mile or something like that. So if you go a mile, you go quite a bit longer than you would if you went a kilometer. All right? I'll have to look at that number. I should know it off the top of my head. I just forget. But that's 1 kilometer. Let's look at the smaller numbers on here. See the bigger numbers? There's a 10, a 20, 30, 40. Okay, do you see that distance right there? Well, actually, let's do this. Let's do one smaller than that. Even smaller. See the 1, 2, 3. I know it's hard. It's kind of dark in here. But 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many numbers does it go all the way up to? If I start counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and I keep going, what does it eventually get up to? Anybody see? Look up here. Look at the ruler. Look at it. What number does it get to? Do you see all the ones? There's 50, 60, 70, and then 90, 91, 92. Come on. What's it go up to? 100. Very good. Okay, it goes up to 100. All right, so what's each one of those? So if I went like that, see that little distance right there where my fingers are? That's about 1. What do you think that's called? It's a centimeter. That's right. It's a centimeter. So there's 100 centimeters in 1 meter. So a centimeter is pretty small, isn't it? Okay. But look at the real tiny ones. I mean, almost, if you're in the back, you probably can't even see it. It probably looks like just a blurry kind of line right there. But if you're up close, see up close? The really super tiny, see up close? The really tiny numbers, there's 10 of those. If you counted them up, it's kind of hard. You got to get really close up. But if you count it up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 of them for 1 centimeter. What do we call those little tiny ones? Millimeters. They're millimeters, okay, and that's right up there. Do you see it? There's 10 millimeters for 1 of those centimeters. Everybody good with that? And I think I have a ruler. Did I put a ruler? Let me just check. Wow, look at that. I sure did. Wow, I was thinking, wasn't I? Look at that. See, there you go. So from here to here, from 0 to 1, that's 1 centimeter. Now this only goes to like 20 something, maybe 21 or so. If this stretched all the way out to 100, then that would be a meter, wouldn't it? The whole thing would be a meter. But this is not a meter. But from 0 to 1, that's 1 what? Centimeter. But there's little tiny ones in there. How many of those are in between 0 and 1? If you counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 of them, so that's a millimeter. So millimeters are really small. Centimeters are a little bit bigger. Now, sometimes they break them up into tens. If you look at this meter stick in front of you, you see a big 10, 20, 30. Even in the back, you might even see those, can't you? Do you see the 10, 20, 30? Yes? Nod your head if you can. Yeah, okay. 10, 20, 30. They call those decimeters, but it doesn't seem like in science and things that they use that very often. Okay, they could use that, but they don't really use that very often when you use the metric system. But that's what they are, though, decimeters. Now think of the prefixes. The prefixes are important. Like centa. What do you think centi? C-E-N-T-I. What do you think that means? 100, right. Give me a word that you probably use that really doesn't have much to do with math. Give me a word that deals with centi or century, right, good, C-E-N-T, all right, century. And the century has what? 100 years, right? So the word cent, C-E-N-T, means 100. What's that? A centipede, good. That's another one, a centipede. You've heard of a centipede, right? A little wiggly bug thing, and that's got 100. Well, I don't know if it technically has 100 legs, but that's why they named it. And because there's a millipede too, and I don't think a millipede has exactly like 1,000 legs, but that's what they're named, and that's kind of what they used it for. All right. So cent. Well, what's another one? Like money, right? How many cents in a what? In a dollar. How many cents in a dollar? 100, right? Why? Why do we use cents? Because of that prefix cent. C-E-N-T is centuries. So centimeters. 100. All right. Pretty easy, right? Kilo is another one. Okay, that means, what do you think? A kilo or a K? I don't know. Do you remember? You guys are probably too young. What year were you guys born?
94.
94. Yeah, you're probably just a real little kid. When the millennium, 96. Wow. Okay, when the millennium came around, I don't know. Does anybody remember that? The year 2000. What was the big catchphrase? Instead of saying the year 2000, they said what? Y2K. Very good. Why did they say Y2K? Year 2K is for kilo, and it's 1,000. That's right. So the year 2000. That's why they said Y2K all the time. Because I don't know if you probably don't remember. You might have been too young, but there was all this panic about whether the computers were all going to crash at midnight, the year 2000. The last day of the year. Guys, remember any of that kind of stuff? Did you read about it in your history books? See, for me, it seemed like that happened like yesterday, but now it's probably in history books where they talk about Y2K. That's how old I'm getting. So anyway, there you go. So that's the unit of length. These prefixes can be used for a lot of things too, and not just length. They could be used for like volume, like liters. We deal with liters all the time. What do you probably drink? That some of you probably drink it every day, a soda, and you buy it in what? In 2 liters, right? You get a 2-liter bottle. Would you agree? All right. But you could also have smaller ones. If you look at the cans, take out any like can or box or anything in your food closet at home, right? You pull it out, and you'll probably see it's so many ounces, and then it's so many what? Probably like grams, or it might say what? Milligrams, or something like that, okay? Or like I said, kilograms. You probably heard of that before, right? Kilograms. So the prefixes can be used for all kinds of different things. They can be used for volume. They can be used for weight. They can be used for length. But all you got to do is remember just a few of those prefixes. That's the cool thing about the metric system. I try to convince my kids every year that the metric system is so much easier, it's so much cooler to use than what we use all the time. Think about it. When you use the metric system, you've got centimeters, millimeters, okay? You've got centigrams, milligrams. You have centiliters, milliliters, right? You probably heard milliliters before, right? Right? You use the same prefixes with different numbers. But think about the English system. What do we have? We have inches, we have yards, we have feet, we have miles. None of those things relate to these other units of measurement, do they? Like, what about volume? We measure, you buy a what of milk usually? A gallon of milk. And then you break that down. You got what? Quarts and pints and cups. Do they have any correlation at all with the length system, like meters like inches and feet and yards? Nothing corresponds. Everything's a different word. Isn't that crazy? And we are, as Americans, we're so stuck on this English system. Even the English don't use the English system anymore. Even the English use the metric system. It's just kind of crazy that America hasn't just really wrapped its arms around the metric system. I mean, we're starting to, little bits here and there, right? Like with sodas, you buy a 2-liter, or you go to 7-Eleven or Wawa or whatever, and you get a 1-liter, so you kind of know instinctively how much those things are. But you just drive up into Canada not too far, and I remember my wife and I took our honeymoon to what's the waterfall? Niagara Falls. Sometimes my mind, you got to help me out sometimes. We went to Niagara Falls, and we took a trip, and we stayed on the Canadian side, and we took a trip to Toronto, and we had to stop and get gas. And I was like, wow, look how cheap the gas is. And I forget exactly what the numbers were at the particular time, but I'm thinking per gallon. What do you think they sell it in the gas station? Per liter, right? And so a liter's a lot smaller than a gallon. I thought, wow, this gas is really cheap. And I'm like, ooh, that's only for a liter. And then I actually figured it out, and it was actually more expensive than it was at home for a gallon. But but in Canada, the road signs are all metric. I mean, everything you buy, almost everything they do is metric system. Except the football field. I mean, they play football, regular American football, or gridiron is what they call it in Canada. But they still their field is measured in yards. All right, they don't measure it in meters. I guess it's just old-fashioned. It used to be yards, so they always kept it yards. So that's kind of different. So anyway, there you go. So we got a couple Canadians here. Some of you guys already know them. Talk to them about the metric system. Javier, you guys use metric system all the time, don't you, at the islands? Is there anything in miles per hour? Is it all in kilometers per hour? Everything's in kilometers per hour? Yeah. And the temperature, too, right? Yeah. Temperature, you don't even use Fahrenheit, you use Celsius, right? Yeah. So I don't think there's another country in the world that uses the English system predominantly except for the United States. Don't know why. Anybody give me a reason? We're just bullheaded, I think. I think we're just stubborn. I think sometimes that's part of what makes America great, just being stubborn. But sometimes I just think it's to our detriment. Anyway, let's do some math, okay? Let's do some of this stuff. What we're going to do is we're going to change these units. Now, remember, this is equal. 1 kilometer is equal to 1,000 meters. 1 meter is equal to 100 centimeters, and 1 centimeter is equal to 10 millimeters. So let's do this thing right here. Okay, now you can take some notes on this stuff. So let's say we had 4.2, let's say, kilometers. And what I'm going to do is we're going to do some conversions. So I'm going to convert 4.2 kilometers. I'll just put a little arrow. Sometimes they use the word to. So 4.2 kilometers to, let's go to meters. That's pretty easy. I might do this a little bit differently than in the book. So if you look in the book, it's basically doing the same thing, but just the look of what they do is a little bit different than what I do. I like my way better, so I'm going to do it my way. So watch what we're going to do first of all. First of all, do we have a conversion between meters and kilometers? Yeah. We have 1 kilometer and km. Did they show the shorthand version? Yeah, they did. Km is kilometer. Okay. 1 kilometer is equal to, do we know how many meters in a kilometer? Look on your list. 1,000. Okay. You guys did write that list down, didn't you? Yeah. Right there. Okay, good. Good. All right, so 1,000 meters equals 1 kilometer. That's very important. We're going to use that. Now let me just backtrack. Before I actually do this problem, let's go back in time a little bit when you were a kid and you learned fractions. Do you remember if you had, like, I'm just picking a number, 3 over 3. What's 3 over 3 equal to? It's equal to 1. Okay, what's 17 over 17 equal to? It's 1. It's not 1 times 3. It's not 1 times 17. It's just the number 1, isn't it? Let's go algebra. Let's go x over x. What's x over x equal to? It's not 1x. It's just 1. Look, anything divided by itself is equal to what? 1. 17 over 17 is 1. This could be a 17, couldn't it? 17 over 17. So what would it be? It would be a what? Be a 1. So it doesn't matter what that number is. Any number divided by itself is not equal to 1x. It's just equal to what? 1. The number 1. Not itself, the number 1. All right? So it's equal to the number 1. It's very, very important to understand for what we're going to do in this whole lesson right here. So anything divided by itself is equal to 1. So watch this. What if I said this? What if I said 1,000 meters divided by 1 kilometer? Now remember what I said. Anything divided by itself, okay, is equal to 1. Look at 1,000 meters and look at 1 kilometer. They're equal. They're the same thing, aren't they? Isn't 1,000 meters the same thing as a kilometer? So what's anything divided by itself? It's 1. It's not 1 meter. It's not 1 kilometer, is it? It's just what? Talk to me. The number 1. Okay? Let's try that one more time. 1,000 meters over 1 kilometer is equal to what? 1. Okay, it's equal to 1. Just the number 1. Not 1 meter, not 1 kilometer, just the number 1. Everybody clear on that? Yeah. I think that's very important. We got to clear the air on this. Okay? Make sure that we understand that, because what we're going to do really, really depends on understanding what we just did right here. All right, let's do this. Here's what I do. If I'm taking this and converting it to meters, kilometers to meters, this is what I do first thing. I go 4.2 kilometers, and I always put it over 1. Now, that's not something over itself. That's just over 1, which is itself. Would you agree? 3 over 1 is 3. 10 over 10, or 10 over 1 is 10. 1,000 over 1 is 1,000. You follow me? Okay, so that's just 4.2 kilometers. What I'm going to do, though, is I'm going to get rid of kilometers and I'm going to change it to meters. That's what I'm trying to do. I want to get rid of the kilometers, change it to meters. This is what I do. By the way, we call this a unit multiplier. Write that down. Multiplier. My writing is really bad. It'll get better as the year goes on. Is that right? Actually, I write a lot better than this normally, but I've had a whole summer off from writing on this thing, so I got to get... This is a unit multiplier, this thing right here. Okay, when I have something divided by itself, I call that thing a unit multiplier. Unit means 1. Look it up. Okay, if you talk about unit, that means 1. So what I'm going to do is this. I'm going to multiply this by a unit multiplier. What am I trying to get rid of? I'm trying to get rid of what? The kilometers, right. And I want to change it to meters. So what I'm going to do is I want to get rid of that kilometers. Now when you multiply fractions together, you've done this stuff before, right? Watch. If I put kilometers down here and I multiply that together, what's going to happen with that kilometers? They're going to cancel each other out, right? You've done that with fractions, haven't you? When you multiply fractions together, okay, the kilometers will actually cancel each other out. What do I want to change it to? To meters. So where do you think I'll put meters? Up top. That's right. Okay, I want meters on the top. I want kilometers. So whatever I'm trying to get rid of, I put the kilometers down here on the bottom. Now, what numbers do I put here and here? How many kilometers equals how many meters? What do you think? 1,000 meters is 1 kilometer. So I put 1,000 with the meters and I put the 1 with the kilometer. I've been asked this question before. Does it matter which one you put the 1,000 on? Yeah, absolutely. I'm not going to put 1,000 kilometers, are I? Am I? Am I going to put 1,000 kilometers equals 1 meter? No, 1 meter is this long. How long is 1,000 kilometers? You'd have to get in a car and it'll take you half the day to get 1,000 kilometers. Okay? So that's not equal to each other, but 1,000 meters is equal to 1 kilometer. Does that make sense? You got to understand why I put the 1,000 with the meters and why I put the 1 with the kilometer. Because right here, look, 1 kilometer equals 1,000 meters. All right? Okay, so watch what happens now. The kilometer cancels out. And look what I'm left with. I'm left with meters. So now all I got to do is what to this number and this number? Multiply them together. That's why it's called a unit multiplier. Do you see that right there? It's multiplying. This is a unit, right? Because it's a 1, isn't it? 1,000 meters and 1 kilometer, 1 over top of each other, that's equal to 1. So really, all I'm doing is multiplying by a 1, right? Do I change the value of it if I multiply by 1? If I take a 3, multiply it by 1, did I change it? If I take a 17 and multiply it by 1, did I change it? No. If I took 4.2 kilometers, multiplied it by a 1, that's a 1, isn't it? Did I really change the value of it? No, I didn't. But I got rid of the kilometers and I changed it to meters. So you can do this in your head. How do you multiply by 1,000, especially if you have decimals? Okay. Yeah, move the decimal how many places? 3 places. 1, 2, 3. I'll have to stick a couple zeros on there. So it's 4, 2, 0, 0. What's my units, though? It's not kilometers this time because the kilometers canceled out. It's meters. That's right. So it takes 4,200 meters to make 4.2 kilometers. And that's how you do the conversions. And you would circle that. This is what I want to see. See all this stuff right here? This is what I want to see when you do the problems. I want you to write the problem out, show your conversions, show your work, your math, all right? And then show your answer and circle it. All that stuff in the box, you don't have to put the box there, but all that stuff in that box right there is what I want to see on your homework when you do this stuff. Everybody good with that? Okay. Now that took a long time to explain. It doesn't take near that long to actually do the problem, okay? It always takes long at first to explain it, but let's do another type. Look, I got all these different colors too. Let's use this nice blue. How about that? Let's do another one. I'll tell you what, let's do another metric one, then I'm going to show you some. Here's a good one. 17 mm. What's mm? Millimeters. And I want to change that to meters. Okay? Now 17 millimeters, is that really big or really small? Really small. Millimeters is really small. 17, okay? If you wanted to, you could look up here, count 17 of those little tiny things and find out how much of a meter is that. Now, is it 1 full meter? Is 17 millimeters? Look, there's There's 1. So 17 would be about from here to here. Is that 1 meter? It's going to be what? Is it going to be bigger than a meter or smaller than a meter? Smaller than a meter, right? So it's going to be probably a decimal, isn't it? All right, so keep that in mind. Think about what you're trying to do. Instead of just plugging numbers in and just doing the math, think about what's going on when you do this. So first thing I do is this. I put 17 millimeters and I put it over, what did I do on the other problem? Put it over 1. And then I put my multiplication. And then I put another fraction bar here. Now this time, what am I trying to get rid of this time? The millimeters. So if millimeters is on top, what am I going to put on the bottom? Millimeters. Why do I put it on the bottom? So they do what? So they get rid of it by canceling out, right? Okay. Now I want to change it to meters, so I put meters up here. Now I got to figure out how many meters equals how many millimeters. 1,000, which one? Millimeters. That's good. It's 1,000 millimeters. 1,000 millimeters equals what? 1 meter. Was that on your list? I don't know if they listed it like that. Yeah, they didn't say 1,000 millimeters, but they did say 10 millimeters equals a centimeter and 100 centimeters equals a meter. So 10 times 100 is 1,000. Do you see that? But we actually talked about that too when I showed you the meter stick. All right, that there's 1,000 millimeters in 1 meter. That's your unit multiplier. So really, this stuff right here is just equal to the number 1. Everybody understand that? Okay, that's really just equal to the number 1. So really, I'm not changing the value of it. I'm just changing the units. So look what happens. Let's do this. I always like to cancel it out. Right? So the millimeters cancels with the millimeters. Now this time we're not multiplying by 1,000. What are we doing? We're dividing by 1,000. So instead of moving the decimal to the right, which way do we move it? To the left, okay? Don't be so quick to pull out a calculator and stick it in a calculator, okay? This stuff you can do very easily. So I move it to the left. So my decimal's sitting here right now, isn't it? Right after the 7. So I move it to the left. How many places do I have to move it? Cleo, you with me? Snap out of it. There you go. I see you drifting. Move it to the left. How many places? 3 places. So we go 1, 2, and then what do we got to stick in there? A 0. So what's that going to give us? 0.017 what? Meters. Okay? That's a small number of meters, isn't it? That's a lot less than 1. It's 17 1,000th, okay, of yeah, I guess you could say it's 17 1,000th of a meter. And that's your answer. Because you divided. When you divide by a power of 10, you move the decimal to the left. If you multiply, because you're making it smaller, right? If you're dividing by a number, you're making it smaller. Moving the decimal to the left makes the number smaller. If I'm multiplying by a power of 10, multiplying by 1,000, I move the decimal to the right because that makes it bigger. It makes it a bigger number. Does that make sense? You're allowed. But on stuff like this, I really want you to try to have a little discipline and try to do this without a calculator. If you want to use a calculator to check yourself, that's fine. On a test, I'm not going to stand over, sit over your shoulder. So, oh, you can't use a calculator on this problem, but you can use it on this. No, you can use a calculator if you want to. But believe me, look, I'm a fan of calculators. I like calculators. Okay, I have no issue with calculators, but I don't like them when they're overused. Okay, I don't like for every time you see a problem, boom, pull out the calculator, plug it in. I want you to think a little bit. I'm going to try to challenge you a little bit this year to try to do some problems without a calculator. Now, sometimes it's way quicker, it's way easier to use a calculator, and I'm all for that. Okay, I have no problem with that. But on stuff like this, was it really necessary to put that in a calculator? No. By the time you would have pulled the calculator out of your book bag, turned it on, right, taken the case off, turned it on, and punched the numbers in, I could have been on to the next problem by then. All right? So on simple things like this, let's try not to use a calculator. Okay. I've got another unit thing here, and there we go. Let's do unit of length again, and let's scroll down. I just copied that is what I did. Alright, where are we? Boom, there we go. Let's give me some blank spots. Oh, look at that. Okay, now we're talking about the unit, or the English units. We talked about the metric. Now the math is really the same. Okay, now on this case, we're using some crazy numbers. Look at this. 12, 3, 5,280. What's up with that? Wasn't it a lot easier when we did powers of 10, right? When we just had to move decimals over. But now we got these crazy ugly numbers. That's why the English system should be outlawed in the United States. Well, I don't know if it should be outlawed, but I mean, I think we should use the metric system a little bit more. All right, let's take a look at, let's do an example. And you probably knew these already, right? 12 inches a foot, 3 feet is a yard. Maybe you didn't know this one, but 5,280 feet is 1 mile. All right, so that's a pretty important number to know. Let's do this one right here. Let's go, this one's actually kind of easy. 39 feet, and we want to convert that to yards. Okay? So what do? We take 39, put the units, don't just put a 39, put the units there and put it over 1. Everybody's got that part of it, right? Everybody can do that. So you take your number, you always put it over 1, and then you got to figure out what is your unit multiplier going to be. Well, what are we trying to get rid of? Feet. Right. So what do you think feet's going to go over here? On the bottom. Right. Why does it go on the bottom? Because we want to do what to them? Cancel them out. Exactly right. So what can I do? Can I change from feet to yards? Look up here. Do I have a conversion that goes from feet to yards? Yeah, right here. 3 feet equals what? 1 yard. So I'm going to put feet up. I'm sorry. I'm going to put yards up here. So now what number goes here? What number goes here? Well, how many yards equals how many feet? 1 yard equals what? 3 feet. So it's very important that you put the 3 with the feet and the 1 with the yard. You see that? They have to equal each other. This thing on top and this thing on the bottom have to be equal to each other. They got to be the same. Because really what we're doing is we're multiplying by a 1. That whole thing is just equal to the number 1. All right? So you go home tonight. Your parents ever do this? Does anybody eat dinner together anymore? No. No? Good. Some people do. We hardly do at our house. When I grew up, though, every single meal was always at home on the dinner table. My dad was a teacher, and he would always ask us, "So, kids, what'd you learn in school today?" You know, anybody? Does that ever happen at anybody's house? Good. Good for you. Good. And so, so what you can say, well, I learned how to multiply by 1. And that's basically what we did today. And you're like, what are they teaching at that school anyway? You should already know how to multiply by 1. But that's what we're doing. We're multiplying by 1. All right? And if you can remember that, it makes things pretty easy. So let's see what we can do here. The feet cancel out, don't they? Now, you could do this in a calculator, I guess. This is not quite as easy as just moving decimal places over, but they rigged this, didn't they? They rigged this so it works out pretty nice. 3 does go into 39. 3 goes into 39 how many times? 13 times. You see that? Goes into 3 once, goes into 9 3 times, 13 times. Right? That was a nice way to do it, wasn't it? Right? And not relying on a calculator? Yeah. You guys are going to go out of here thinking Mr. Hambrick hates calculators, but I don't hate them. Okay, I got nothing against calculators, but I want you to be able to use your brain. All right, when you can. All right, when it's possible, when it's easy, use your brain. Okay, so here we go. The feet canceled out. I got a 13. So what are my units in? 13 what? Yards. Very good. So 39 feet equals 13 yards. Let's sit back and think if it makes sense. Does that make sense? If I have 13 yards, I'm going to have more feet, right? Then I will have yards. Yeah, that definitely makes sense. Everybody got that? Yes. Always sit back and make sure your problem kind of makes sense to you instead of just doing the math and writing down an answer. Look at all the stuff I did. What did I do? I wrote the problem, I showed my work, and then I wrote down my answer and I circled it. That's how I want you to do these, okay, when it comes time to do your homework. Everybody with me on that? Don't just put number 7, 13 yards. Don't do that. Okay, I want to see all, I want to see all this stuff right here. That's what I'm looking for. I'm a math teacher. Math teachers always picky about stuff like that, aren't they? Yeah. But for a good reason. What's that? On a test, I'm actually probably more interested in the answer. Okay? On the homeworks, I'm definitely interested in your work. All right? Now, on a test, I would be careful of just trying to do too much in your head because there are times where I'll look back to see what you did. We'll talk about that later because I don't really give partial credit on a test. Let's do another one. You write all these things down, right? You got those in your notes? Okay, so I'm going to pop this up a little bit. And let's do this. 6,600 yards. And I want to convert that to miles. Okay? Go ahead and try that. I bet you can. Well, actually, this one might be a little bit tougher. I'll tell you what. Let's do this one together, okay? So you can start it off, though, can't you? Put 6,600 yards. Put that over what? 1. Good. Now, look on our list. Do we have an exact conversion to go from miles to yards? No. We got miles to what? Feet. So let's think about it this way. We might have to do 2 steps with this. We might have to change it to feet first. And then we can go from feet to what? To miles. Did you follow me on that? So we can go, look, we can go yards to feet, and then we go what? Feet to miles. You see that? Because there's not an exact conversion to go from yards to miles. Now, there is a number, but let's just do it like this. So what are we going to do? I can't go directly to miles, because I don't know how many yards equals how many miles. But I can go yards to feet. So let's do that. So if I got yards here, yards on the bottom. What am I changing to? Am I changing to miles right away? No, I'm going to change to what? Feet. So I can do that. Look, the yards cancel out. How many feet, how many yards? 3 feet, good, and 1 yard. Everybody good with that? So right there, I changed it to feet. Now, I've got feet. Can I go directly from feet to miles?
No.
Look on your chart. Yeah, there is. There's a conversion to go from feet to miles, isn't there? So let's do that. So if feet's on the top, what am I going to put here? Feet on the bottom, so they cancel out. And then what goes on top? Miles. See what I did? I went from yards to feet, and then I went from feet to miles. How many miles equals how many feet? 1 mile, 5,280. Okay, that's a number you should know. All right, if you didn't know it before, know it now. All right, it's a pretty important number. Took a class trip years ago at my other school to Colorado and Denver. Denver, they call it a mile-high city. And actually, on their the steps to the Capitol building, there's actually a little plaque on one of the steps, about halfway up the steps, and it says elevation 5,280 feet. So that means, guess how high I was standing? 1 mile high above sea level. Okay, that's 1 mile above sea level. And actually, in the stadium, at the Rockies Stadium, where it's in Denver, they actually, I don't know if you saw this, but they showed this one time when the Phillies were playing there. They have 1 row of seats, goes all the way around the whole stadium. All the seats are kind of like a blue, like a dark blue, but the 1 row of seats around the stadium is a purple, because that's their color. What do you think that 1 row of seats is representing? Why do they make it purple? Just because it looks cool? What do you think? It's a mile high. That's exactly 5,280 feet above sea level. All right, so that's an important number to know. All right, so when you go to Colorado and you go mile high, that's how high you are. Okay, so like we went to Pikes Peak. Pikes Peak was like 14,000 plus feet high. 14,000. So off the top of your head, around how many miles high is that? It was like 14 plus. Let's say 15. Let's say 15,000. This is about 5,000. Pikes Peak is around 15,000. So how many miles high would that be? About 3 miles. About 3 miles. Okay? Because 3 times 5,000 is 15,000, right? So approximately. I'm saying approximately. So it was around 3 miles high. So Pikes Peak is way up here. Here's sea level. Pikes Peak is here. And then where's Rocky Stadium? It's like right here. That's how much bigger Pikes Peak is than the highest point. I don't know if Mile High is the highest point in Denver or not, but anyway, right here. In Delaware, I think the highest peak in Delaware, I didn't look it up.
Please excuse this interruption. All students who have Mrs. DiGregorio's health class or Mrs. Richardson's health class, that would be your next class, so please report to the library for that. That's only students in health with Mrs. DiGregorio and Mrs. Richardson. Go to the library next, please. Thank you.
Anyway, Delaware is only I think like 300 and something feet high. That's the highest peak in Delaware, is like 300 feet. So here's Pikes Peak in Colorado, 14,000 feet. Here's Mile High, and Delaware is about that high right there, okay? Because we're close to the ocean, and we don't have big old mountains and stuff. So that's kind of interesting. Let's do this problem real quick. We only have less than a minute left. Watch this. The feet cancel out. Now, on this, I would definitely use a calculator. Who's got a calculator? Okay, pull the calculator out really quick. Do this. Put 6,600 times 3, and then take that number divided by 5,280. And tell me what you get. 6,600 times 3, and then divide that by 5,280. Should get like 3.75 around there. Is that right?
Yeah.
Good. 3.75 what? Miles. Now look, that's pretty high. 6,600 yards is pretty high, isn't it? It's 3.75 miles. Okay, enough of that. So what I'm going to have you do is page... Now it's kind of weird. They call it P because it's at the beginning. I don't know if it's I don't know what the P stands for, but anyway, it's P5, and it's section... Remember, we always put the section on there. Section 01, and we are going to do... let's do numbers 7 to 27. These shouldn't take too long, okay? So that's 21 problems. It's not too bad. All right, so it's page P5. This is what you're going to do. You're going to do 7 to 27. And remember, so it's going to be like this. You put the number, you write the problem, okay? So you write out the problem, you show your work, and then you write the answer down. Okay. I'll tell you what. Since the bell just rang, let me collect those class info sheets. Well, actually, you turned them in yesterday, didn't you? Okay. If you did not turn it in, give it to me now. Okay. This class info sheet. If you didn't turn it in yesterday. All right. Have a great day.